In this lesson, we're going to talk a little bit about matter. We're concerned about matter in environmental science because matter is what cycles through ecosystems. We need to be concerned about how that happens, and we also look at the energy that's involved when that happens. So we're going to talk a little bit of chemistry and a little bit of physics right now. So matter is in chemical forms. It exists with elements and compounds. So thinking back to the beginnings of biology, and if you've taken chemistry, elements are those building blocks, right? That's what's on our periodic table. Elements make up our other matter. They're made up of atoms of all the same kind. Those elements get combined together to make compounds. And how those compounds are fixed together is going to determine how they behave. And what elements are fixed together are going to determine the properties of that matter and how it's going to behave in the environment. So we're not going to get into chemical composition so much. We're going to talk in generalities for the most part. There are some compounds that you're going to have to know, like water and carbon dioxide. And when we get to those ones that are important, especially as we move through, I'll make sure that I tell you which ones are the ones that you need to know. But we're not going to be memorizing the periodic table or anything like that. So one of the things that we also look at is with an atom, we can have ions, which is where it has that positive or negative charge, and we're concerned about the ion, particularly with hydrogen, because of the pH scale. So the matter that we're concerned about, a lot of it's either going to be acidic or basic, and when we talk about how acids and bases are added into the environment, it's going to impact ecosystems in different ways. So we're not going to be so worried about things like how acidic is a tomato or a lemon, but we want to know that when acids are introduced into an ecosystem, our critters that are in the ecosystem and our plants, they have a range of tolerance for acidic things and for basic things. And if you get them outside of their range of tolerance, then organisms won't reproduce, they won't be able to photosynthesize, it's going to decrease water quality, there's things that are consequences of those, that either a basic or an acidic solution being added into an environment. So that's why we're concerned about the pH scale. We're also concerned about the quality of matter, particularly when we look at our energy resources and our mineral resources, because the higher quality matter, if we can get that in its pure form, it takes less energy to do that, and so then we're expending less energy, which means that we don't have to mine more for the energy resource. It generally also means less pollution as a byproduct. So when we talk about ways of lessening impact, we look for higher quality matter as opposed to that lower quality matter. So matter, particularly when we speak about moving through ecosystems, matter can change form. So it can go through states, right? We know our states of matter are solid, liquid, and gases. It can have a physical change, or it can have a chemical change, but atoms are not created or destroyed. So, and it's not actually finished here on the slide. But there's not atoms being created or destroyed, they're just changing form. They may be recombining with other atoms to make different compounds or something like that. And we may have some that is no longer attached, like if something burns, for example, we have some of like if it was wood that was burning, some of that wood becomes a gas. Some of it becomes ash and actually can float away and like leave the area, but it's still not created or destroyed. It's just changing forms. So law of conservation of matter is important. When we have that physical or chemical change, matter is not created or destroyed. It's just changing forms on us. There is a similar law that deals with energy. So when we have that change in form, we have energy that's released. So the energy is not being created, but it's being released. It's going from potential energy to becoming kinetic energy. So our laws of thermodynamics, this is where we go back over into the realm of chemistry and physics a little bit. Just like we can't create or destroy matter, we can't create or destroy energy. We changes from one form to the next, and which leads us to that second law of thermodynamics, which tells us the amount of usable energy always decreases. So it's the law of entropy, which tells us that as we utilize that energy, that not all of the energy passes in the same form from one state to the next. So, for example, when sunlight comes down and reaches the earth, there's a great deal of energy that leaves the sun and makes it to earth. Some of it's absorbed into the ground as thermal energy. Some of it is captured in plants for photosynthesis, but it's just a tiny, tiny fraction of what comes from the sun actually makes it through photosynthesis and into plants and into the leaves and into the chloroplasts of plants. That plant uses some of the energy for growth. So it will get bigger, like it does in this picture. It will use some of it for reproduction. It makes flowers. It produces seed, it produces fruit, okay? But each time that happens, we have some waste heat that goes along. So from the sun down to earth, we have some heat that's lost as waste, that the plant can't use it all. And then as it goes through photosynthesis, it will lose again some of that energy to waste heat. And then the person here who's picking the apple, as they're eating it, all the energy that was in the apple isn't all usable for this person here either. Some of the person is using as for work, to chew, to digest. Some of it is lost through our body through heat. Okay, that's why we feel warm. We're actually letting off heat in there, and then we can use some of that to do mechanical work or to do things like dig the hole and plant another tree in here. But the point is that all the energy that came from the sun was not available to the man. As every conversion occurred, some of that energy was lost. And as a good rule of thumb, it's approximately 10% moves through, and about 90% at each stage is lost to waste heat, approximately. Depending on the ecosystem, that can vary a little bit. Now, when we talk about our sustainability and how matter moves through our ecosystem, if you will, or our human systems, we can either model nature or we can not model nature. And this first diagram is of an unsustainable, high throughput economy where we are not modeling nature because there's lots of inputs coming into it. So inputs from the environment are things like natural resources. So this could be wood, water, metals, fossil fuels, those kinds of things. We have our energy, those inputs are in the form of matter and energy. We do things with those. We make stuff, right? We make products, we make houses, we produce energy. We do lots of stuff with that, and that's what's in this center part here is us making stuff. And as a result of that, we put things back out towards the environment. Things like that low quality energy, that heat, that waste heat. So when you run a car. So if you were to if you run your car, let's say you drive your car for 20 minutes and then you stop and you were to put your hand on the hood of your car, it would be hot, right? That's waste heat. That's some of the energy that we're talking about that's wasted. We also have the more typical wastes that we think about, the trash and the pollution that comes from all of these things that we buy. So in this way, we're not mimicking nature because nature recycles. Nature reuses. Nature works in circles, and outputs become inputs. And so if we were working more like a natural system like our environment does, where things are cycled through, we would have this energy that would be a higher quality energy that would come in. We wouldn't use as much of it because we would be using energy conservation techniques like the types of bulbs that you use, or having better insulation in your homes, or better windows, or closing the gaps, or things like that of those nature where we don't need to use as much energy. We would have lower amounts of matter, and we would utilize our waste and pollution as an input. And so we would take things out of the waste stream to be able to be recycled or to be reused, and that they would become inputs into our system. And this is what it means to be sustainable low waste. And it means that instead of being a throughput society where everything just goes straight through it okay, straight line through it. We have things that are our outputs that can become our inputs again, and so that we have lower amounts of wastes that are going out into the environment. So in this section, there's a short quiz, and then we're going to move on to talking about ecosystems a little bit more.